So if we're going to write this as some number in polar form first, then it might be helpful to at least draw it, take a look at it, etc.
Okay.
So that's going to be square root of 5 this way and -1 this way. Not necessarily drawn wonderfully to scale, but that's okay. So here's our point. Now, we need to figure out two things. We need to figure out what R is, and we need to figure out what theta is.
Okay, so R will be the square root of 6, right?
Yes. So if you take the square root of 5 and square it plus -1 and square it, you'll end up with the square root of 6. So, okay, nothing big and wonderful there, but it is what it is. So square root of 6. And now I need to figure out what theta is. So, okay, not too many good choices here because all of our choices are going to involve some square roots. Correct. So just pick one.
We can do the sine. 1 over square root of 6. -1 over square root of 6.
-1 over the square root of 6. So theta equals sine inverse of -1 over root 6. Now, let's put our calculator in radian mode. Actually, let me do it up here. And unfortunately, it's going to take a moment for my software to open up. But when you calculate the inverse sine, keep in mind that the inverse sine is going to give you an angle between -pi/2 and pi/2. So it's not going to give you, say, 330 degrees. It's going to give you -30 degrees or -pi/6 instead of 11pi/6. All right, this is already in radians. Let me clear this out. Second sine inverse, I should say, of -1 divided by the square root of 6. And bam, like that. Now that's our answer in radians. Well, I want an answer which is, positive. I want a positive angle. I don't want a negative angle.
So yeah,
something between 0 and 2 pi. So instead of going this negative angle, -0.42 something, so -0.4205 or whatever it was.
It comes up to 4.8.
Yeah. If you add 2 pi to this, you're going to get an equivalent angle, plus 2 pi. And that angle will be something between 0 and 2 pi. So let's see, plus 2 pi. Bam. So 5.86. Great. So now I can write my angle in polar form. Let's do that. So it's going to be square root of 6 times cosine of whatever that mess was.
5.862. Are we doing equals?
Well, let's just hang on to this for a second. 5.862 plus I times the sine of that same angle, right?
Correct.
2 parentheses, 1 to close off this, 1 to close off the whole thing. That's going to get raised to the 8th power. Now, it might be easier for us if we wrote this part in exponential form, right? So how would I do that? Well, that's just going to be square root of 6 times e to the I times 5.862. And that's still all to the 8th power, right?
Correct.
Now, at this point, it might be helpful to save this number in someplace. So I'm going to store that in X. So I'm going to hit store in X. Okay, fine. Looking good there. Let's go back here. If I raise this to the 8th power, this exponent multiplies this exponent and the exponent here. Now I could rewrite that as 6 to the 1/2 e to the I 5.862, etc., to the 8th power. But this exponent multiplies each of those exponents. So let's start with the easier part. What's 8 times 1/2?
4.
4. So this is going to be 6 to the 4th power. And then 8 times this is going to be, I don't know. Let's find out.
You have it stored on
So, yeah, but I'll just hit the times key, times, and it'll take my previous answer times 8. And there you go, 46.901. So it's going to be e to the I times 46.901. Last but not least,
1296.
that's, yeah, 1296 e to the I times 46.901. And then this becomes 1296 times cosine of 46.901 plus I times the sine of 46.901. Now, if you wanted to, I guess, do they want it in the form of A plus BI? Is that what they're all?
Yes.
Yes. Okay. So what we need to do to finish this up is we're going to take 1296 times the cosine of that plus 1296 times the sine of that, and that should finish things up. So let's see. Appears as though I'm going to need this thing twice. So I'm just going to overwrite my old value of x with this new one. So I'm going to hit the store key. Let me clear out all my old stuff here. Clear that out. Store in x. So now I've got that big, long, nice number. And notice I haven't done any rounding. It's important not to round your numbers until the last step. So the first calculation is going to be 1296 cosine of x. Oh, look at that, negative 1264. Plus I times the sine of that. So it's again going to be 1296 times sine of x. And this time I get negative, or 286. That'd be 286.216 times I. So if they ask you to round to the nearest integer, then this would just be 286i and not all this extra stuff. I see they said 3 decimal places, right?
Correct.
Well, that should be correct. I can't see that they're going to look for this. I don't think that they're going to look for that. It said integers or decimals, if I remember you reading the problem correctly.
Correct. But the problem with my lab math was, so I did the same thing you just did, and it told me it was wrong. I went to the example, what they wanted to, you see how theta is cosine of 46.901?
Yeah.
They wanted it between 0 and 2 pi. So
okay, well, we could do that. So was this an intermediate answer that they wanted you to put in an intermediate answer? And because I mean, there's nothing wrong with that. It has some equivalences. I could write equivalent angles to that, but I thought I wanted like this as a final answer. Is that right or no?
Yeah, and I did this. I had the same answer. Something is wrong with my lab math. It wouldn't take it. So when I changed it to the other way, you know, where you minus 2 pi till you get down to below 2 pi, so where it's between 0 and 2 pi, and it still kept telling me it's wrong. I mean, I tried everything. I worked on this question for probably 4 hours, and still nothing.
All right. Well, I appreciate your diligence on that. Let me take a look at this one more way. I mean, the only the only difference I could come up with is just using a different angle or an equivalent angle to this, all right? Because that's several times around the unit circle. That's like 7 or so times around the unit circle. So if I wanted to find a different angle to use here, an equivalent angle, I'd subtract off multiples of 2 pi like you did. But let me show you a little trick here. Now I've got this value stored here in x, right?
Okay.
So x, that's that angle. If I want to know how many multiples of 2 pi I can subtract off, let me just do this. Let me divide by 2 pi. And the integer portion of this will tell me, oh,
there's
this is more than 7 times around the circle. So what I could do is I could take x, let's see, x minus, 14 pi. 7 times, 2 pi is essentially what I'm doing here.
Okay.
And that's an equivalent angle, a coterminal angle, if you want to go back to chapter 2 stuff. So I could take the sine and cosine of that. If this is what I was looking for, an angle between 0 and 2 pi, then okay. This should still give me the same thing that I got with my original calculation. So let me store this. I'm going to store this in alpha. And if I did cosine of alpha, oh, and I forgot to put the times 1296 times 1296, I should get the same thing I got just a minute ago. Yeah, 1264. A minus 1264. So I don't know if they were looking for an angle between 0 and 2 pi. Maybe that was their objection. Don't know.
What would you get for, because I got negative 1263.940, but I guess you rounded, right?
I didn't do any rounding at all. If you notice, I use stored values the whole way. So
That's
if
why
you're
I have a different value, right?
So if you, what's that?
Is that why I have a different value than yours? Because I got 1263.940.
Yes. Yeah. So at some point you used a rounded number. If you notice what I did, all these were exact numbers. I didn't do any rounding at all. The calculator actually has more digits of precision than you actually see. So if I take A, for instance, and then I subtract off 2.918, 2.918, then what you're going to see is you're going to see more digits. So here's a 9106, 2 here is 5, but now you see a couple more digits that it has kind of hidden. So it has more precision than it actually shows. So by using stored values, I'm using all the precision possible, which is why I'm getting these nice exact answers here.
Do you mind doing the sine one more time? I just want to see the answer for the sine to compare it to mine.
Sine of alpha
Of
A
x.
Times 1296. And then if I did the sine of x, let's see, x still has in it that value that we said was equivalent. If I did sine of x times 1296, let me do the 1296 first. Sine of x, I should get exactly the same thing.
2.86.
So if you compare this one and this one, I'm getting the exact same thing.
Okay.
Okay.
And then exponential form, it wants it to 3 decimals. So do you do 1296 e to the I 2.919 or 2.918?
Let's look back here. I put that value in alpha. So 2.919 would be rounded to 3 decimal places.
That's
So
right.
yeah, in exponential form, it'd be 1296 e to the I times 2.919. And hopefully you don't forget the I, because without it, then it's wrong. But that would be your exponential form right here.
Okay, thank you so much. I just kept coming up with like close numbers, but not the exact number.
Yeah, so try using the store key.
Okay. You know, I never knew how to use it, but now I do.
Yeah, it's really helpful. It gives you much more precision. And in fact, I was really happy to see this exact nice even answer here when everything came out. It made me feel a little more comfortable with my final work there.
You know what? While you're on with me, I'm going to put it in the system right now just to make sure it checks out. Because
Okay.
because my lab math kept giving me such
Trouble.
hard time. So
I'm sorry about that.
And then we just want to let you know about it. You know, hopefully it doesn't come on the exam, but hey, it is what it is.
Yeah, well, we got this recorded, so if other people need some help with it, they can get it.
Okay.
So,
Thank you so
thanks for your
much.
question.
Thank you. I
You're
appreciate
welcome. No problem.